Hey everyone, today I'm doing a video on part 4, which is polysurfaces. Now I'm going to go over a little bit of what polysurface is. A polysurface is basically something that is complex in geometry and it's a solid at the end. So as a cube, we can go back to this example right here. We can click zoom select. We can go back to this. We know that this is solid. Why do we know this is solid? Is because a box has, or cube, or a rectangular prism, whatever you want to call it, has 6 faces. So we have face 1, 2, 3, 4, 5, 6. So we know that's a solid. This is, as you click on it, is one extrusion added. But it's an extrusion is still a polysurface. This is also still considered, I think that's an extrusion. This is a surface. This is also an extrusion as well, and this is a polysurface. So, this is still a polysurface, as you can see, but the difference between this type of polysurface, so this is a quote-unquote bad polysurface, because as you can see, there's a giant opening at the bottom. You can see right here this gray. That means it's still an open solid, a quote-unquote open solid. It's basically the same as having this box, but the top and the bottom removed. It's the same concept, so I actually will show you just for visual purposes. So if you have a solid or a polysurface that's completely solid, you can do explode if you want to individually take out a surface. So now you're left with this, and you can delete this, and now you can select each surface, as you can see. So it's basically the same as this, as you can see. Basically the exact same thing. So let's go back to this. So let's say I want this to be a complete solid, like the top and the bottom to be completely, like, quote unquote, like have a top and the bottom, like the cube. The same concept. We want the have a top and the bottom. So I'm going over this because it's very important, and I want this concept to go very far, because this is what makes a good model. Breaks between a good and a bad model. A bad model is basically filled with all these open polysurfaces and not really completed objects. And the model suffers in when you export it, when you render it, when you do anything with it, when you do make 2D, it suffers completely. If you have a solid model that is completely closed, that is actually like a legit solid, like in real life, if you have a pipe, or like a complete, like a cylinder, you literally think of a top and bottom. Or if you have a box, for example, you think of this exactly. Or if you are a current architecture student, you think of this is like basswood. Like this is basswood doesn't have a hole on both sides and no thickness. Because if you look at this is basically the 4 sides, but this surface has no thickness. But when we undo this, explode, we see now it has thickness. Now that's the difference between modeling good and bad, is when you add that extra layer of articulation of thickness, and that's important, or just solid, or just making the object solid. Now, I'm going to go over how we can make this solid. So there's 2 ways you can do this. If you want it to have a top and a bottom, literally if the top side, if I go to front view, maybe it'll be easier to see. If the bottom and the top are flat, you can actually use a command called cap. So if you highlight this, also these 2 are not joined, so what you need to do is, if you have 2 surfaces, or one, this is technically considered a polysurface as well, not really, but anyways, if you have a surface and a polysurface, you can join the 2 together to create one polysurface. So I click join, and it will join the as one polysurface added to selection. So you can actually type in the command called cap. Now this will create the top and the bottom portion for you, actually. So it's like a shortcut, so you don't have to do any like random extrusions in a sense. You don't have to do any make it more complicated than it has to be. So you type in cap, so CAP, and you hit cap, and it will say created 2 caps resulted in one closed polysurface. Now this is a very important part. If you look at where I'm highlighting closed, that is extremely important. I'm going to keep mentioning this because this is so important. Now, what we had before was an open polysurface, and when I redo it, we now have a closed polysurface. And you're wondering if, like, hey, this object is obviously closed. You can see it just from the edges, right? But once if you want an extra layer of assurance, once if you want, what would happen if you wanted to know, like, oh, I want to be 100% sure this is solid. Like, it can look solid, but there's sometimes a gap in between these, and you're like, and the tolerance is too low for you to see just with your eye and the model. And you're like, okay, I want to know. Obviously, in this case, we know because we saw it. Where is it? One closed poly surface. Let me highlight that so you can see. So let's say you want to know. So there's a command called show edges, and this will show all the edges of the object you want to know. So you type in show, and then edges. Hit enter, and it'll show you an analysis right on top. Found 9 edges total, no naked edges, and no non-manifolded edges. So if you want a completely solid model, you want it to say no naked edges and no non-manifolded. You want them to say both. If they don't have both, then your object's messed up. There's something wrong with the object, and you need to fix that. So it'll say the edge color. So if there was a quote-unquote naked edge, it would show in purple highlight. This will show all the edges of the object. As you can see, all purple. And this will show all the non-manifolded. As you can see, there are none. So this edge analysis, is super important. And it's super nice in terms of modeling. And it tells you if the object is good or bad. Straight off the bat. Like, you don't even have to like look. You can just do show edges. So you can do cap, but cap doesn't always work. And I'm going to show you an example on how cap doesn't work. So I'm going to copy this. And I'm going to keep this capped. So I'm going to recap this. And now I'm going to show you what would happen. So I'm going to actually just slice it diagonally. So I'm going to draw a line. So now, here is another lesson combining kind of curves and the surface. We can actually start to manipulate this geometry by just drawing a curve in profile view. So this is a front profile view, and just like that. Just make sure it's this line geometry is, or curve, quote unquote, is what's it called? Past the bounding edges of this object you have, because you're going to be using this later to quote unquote slice it. So just make sure when you draw it's just it extends past this. So I just drew it way over because it doesn't matter. So I did that, and now you're left with this. So what you can do now is there are two things. I mean, if I want to split it, I would use extrude, curve, and now you're like, okay, I want to split it in the top view like this, where the direction I'm going in. I want it to go extrude it perpendicular, but right now it's only going up and down. You're like, oh wait, okay, and you're like, okay, that's not really working. You're like, how do I change the direction? Well, there's something called direction here, and you can actually click it, and it'll say base point for direction. So you just click anywhere on the curve. I just click here, and then make sure your ortho is on, or you don't have to have your ortho on. It should be auto ortho for when you're trying to select a direction point, a second direction point. So I'm just going to click. It doesn't matter what distance, so I can click all the way here or here. It doesn't matter, but just click anywhere, and it'll start to extrude in that direction. Now you can extrude it that's not orthogonal, but I usually just do orthogonal extrusions because it makes it really weird when you do what's it called, non-orthogonal extrusions. Anyways, so we can now start to manipulate it, and we're just going to make it go past this object, and there we go. So now we have our extrusion. And you're like, okay, what does this do? I mean, sure, it looks like it's slicing it, but you can see it's still reading as one object, and it just looks funky now. It just looks like a strange kind of ski slope looking thing. You're like, yeah, I mean, you're right. So, but what we can do now is, now that we have these two, we can actually use a command called split, and this will split two. It can be either a poly surface or a what's it called, a poly surface or a surface. You can use split for pretty much anything. You can split anything. So it can be a poly surface. So this could be the solid, and you could use this surface to split. You can split anything in Rhino. So like, for example, if I wanted to split these two, this is a poly surface to a surface, you can do that. If you want to split a poly surface or a surface to a polysurface, you can do that. If you want to split a surface to a surface, you can do that as well. If you want to split a curve to a surface, you can do that as well. You can split a curve to a curve as well, by the way. You can actually do that. So you can split a curve to not a polysurface because it still has to pierce the entire thing. So that's just to keep in mind. So split is a very versatile command. You can use it to pretty much slice anything in Rhino. Anything you could really think of, you can pretty much slice it, as long as you're using, if you just use a surface and whatever object or whatever line or whatever type of geometry you have, you can use split for. You can use that. That's what you can really use it for. You can use, as long as you have a surface to split with. Like this is like the cutting object. Oh, not object split. So this is the cutting object. If your cutting object is a surface, you can pretty much split anything with the split command. So just make sure when you're splitting stuff, you use a surface. You really want to use just a surface, and you can pretty much split any type of object. I'm repeating that a lot because I want you guys to remember that. That's very, very important, and I think that's the way I learned it, at least. So anyways, let's do split again. So let's do split, and it'll ask, what object do you want to split? Literally, select object to split. So I was like, okay, I want to split this object. And you hit enter. Then it'll be select the cutting object, which is what I talked about. So the cutting object should be a surface. Not always, but 95% of the time, I'm usually splitting with surface. I'm using my cutting object is a surface. 95% of the time. There are some times where I use curves or other objects. But anyways, so select cutting objects, so this, and then you hit enter, and it'll be splitting one poly surface split into two. And you're saying create meshes, press skip cancel, and then now you can see they're split, which is awesome. So we can now we can either delete this or hide it, or put it in a different layer if we need to keep splitting it along that same angle. That we can use that surface. You can also use the layers, hide or use it as a layer. So I turn this into layer 5 or put into layer 5. You can hide it. So if we need to reuse it again, all we do is turn it on and off. We don't have to keep typing hide. So one thing I showed here, you can also use hide instead of using layers to hide stuff. You can actually click the geometry and type hide, and it will hide it from the view. And if you want to re-see it again, you just literally type in show, and it will show it again. So I'm going to keep it hidden, and I don't know if I need to mention this, but Command Z and Control Z and Control Y are undo and redo. You can also type undo and redo. I just use the keyboard shortcuts. So yeah, Command Z or Control Z is like pretty much universal. So yeah, you can use that here. So I'm going to delete the smaller portion, and now I'm left with this. So let's say I have now the geometry, and I just need the top and the bottom profile. So I'm going to cap it now, right? And you can cap it, yes, but I wanted to show you that there are some times where you can't cap it. So this is the reason you can't cap this one, because it's at an angle, right? So you're like, okay, that's fine, I can still cap that, right? I mean, that's easy. But let's say I had front. Let's go back to that front profile and delete this curve. And wait, actually, let's undo split. So we're undoing the split, and we're going to delete this curve, and we're going to redo everything, except we're going to use a curve instead of just a straight line. So we're going to just kind of and now we can just, and now I'm going to scale this down a little because it's kind of big, and do that right here, and move this down. Okay. So now we have that curve. We can do extrude again, extrude, and this time it's already default to this way, or perpendicular to it. And now we can do split, select object to split, which will be this one, and select cutting objects, which will be this one. Okay, cool. Now we have that. So I'm going to delete that small portion and actually hide this in layer 5, like we did before. So we're redoing that scenario, but with the curve instead of just kind of a interpret curve instead of just line, because line it'll still read as the flat geometry. So let's try cap again. Okay, so it capped it, right? But it says, if you read it, it says something a little different. It says One attempted object is still open. The openings did not have a closed planar loops of edges. So read this. This is very important. Closed planar loops of edges. Now you're like, what does that mean? I mean, it just says closed planar. I mean, those are just words. What that means is that the object you cap wasn't flat or wasn't orthogonal or wasn't or flat on or wasn't planar, as it says here. It wasn't. So when they tried closing it, it didn't really work. And the loop of edges are not completely. So when we had that line geometry that we drew that was angled, it wouldn't cap. It wouldn't cap that one because it doesn't make sense, right? It's not. Cap only reads on a flat type of basis, or if it's angled, or if it's angled, it'll work. So if it's like one cut that we did, remember that line geometry that we drew this way? That would work because it's still planar. It's angled at a different plane, but it's still planar. Like inherently, it's still flat. So, sorry, I'm talking a lot, so I'm getting a little thirsty as well. So I may get a cup of water. Anyways, so you're wondering, all right, well, this object's solid. How do I cap it now, or how do I make it solid now? It doesn't really make sense. How do I do that? And the answer is, there are multiple ways to do this. The way I found the easiest is through edge surface. Now, we did edge surface and we talked briefly about it in surfaces, but I think I can go over it in depth in here. Excuse me. Edge surface we can use also to create the quote-unquote cap of it. So let's type edge surface again, right here. Select 2, 3, or 4 open curves. So we can click this one. We know we want this one, and this one, and this one. And we can do enter, and now we have our cap. Pretty simple, but it looks kind of funky. So let's undo that. I usually use edge surface. Edge surface works best when they are opposite of each other. So this and this are semi-opposite. They're not really superbly opposite, but they usually work the best. So you don't have to do all the edges at once. You can do 2 edges. It doesn't really matter. You just need to make sure they are closed. So in this case though, edge surface with all 3 isn't bad because it encompasses the parameters of this. So now we have our surface we have our surface that we created via edge surface. There are other commands, but the one I use the most definitely is edge surface. That's like honestly the best one I've learned. You can do other different ways. You could use no, I'll show you another way, but right now let's do with edge surface. Edge surface is by far the easiest way. Trust me. And then you can click and then join. And then now we're done. And now we can do show edges. And it will say found 9 edges, no naked edges, and no non-manifold, which means the object is completely solid, and that's good. That's good. This is the ideal. And you're like, cool, we got it done. And I'm going to show you another way to do it. But this way is not as efficient, but you can still use this way. So we're like, okay, cool. We got one way down to do it. Let's try one more way. So another way you can do it is, remember we extruded this. We split this along this surface, or extrusion, whatever you can call it, this surface. We can actually use this surface to our advantage by actually using the split command again. If we split the object we want to split the extrusion now. And now if we split and we use this as our cutting object, remember, this is perfect along this surface, because remember, you use this surface to split this poly surface. So if we use split again, and we split the extrusion and then we use the cutting object with the poly surface, we hit enter, and we now get that perfect cap we need. So now let's hide this, and now look, we have our perfect cap. We literally, all we have to do now is click join, and we join the 2 together. Now we still have an open poly surface, of course, we have this, but you can now type in cap because you know the bottom is flat. And that's another way. Now this looks a lot cleaner, quote unquote. The only reason why it's cleaner is because we based it off of an extrusion, which is not as heavy with these the what's it called, the shaded lines. These lines are really just showing how the geometry is created, how many points you use to determine that surface. It doesn't really mean anything as long as it's super intense, but that's another way you can do it. If you want it, this is more aesthetically, it doesn't make a difference even in rendered. Like, this will look exactly the same in rendered. I don't know why it has this weird ripple, but yeah, I don't know why it looks like that, because usually mine don't look like that, so yeah, it looks fine here. Okay, anyways, I don't know why it's rendering weird. Anyways, I usually don't recommend rendered view. When I render in 3ds Max, I could render this object and it won't look like that, so I don't know why it's doing it here. But anyways, yeah, so that is Polysurfaces. I am not done yet, though. I feel like there is a few more things I can touch up on. I just had it. Let me think. I wanted to go over something along the lines of this. So let me copy this, and I'm going to copy from this point, because I know they're the same, to this point. In terms of top profile, they are the same, so not exactly the height, but just the top profile. So as you can see, they're still the same, but the elevation view is different. Okay, so let's say we want to split this object now. Sure, we can do the method we just showed you. Extrude, curve. Alright, let me do that again, because I didn't extrude it long enough. We can do split, or split, select object to split, select cutting objects, and enter. And now we're left with this, and we can delete this, right? And then we can hide this, and now we still have an opening here. And you're like, okay, cool, we can do the same method, we can just split it along that, and we can do split, we can split it along this, or no, sorry, select object to split, which is the extrusion, split this, and now you can join, and now you can hide, and now you have your extrusion, or your object. Sure, you can do all that, but there is a faster way to do that, instead of using, because remember, this is already solid. So if you have something that's already completely closed like this, so this one's completely closed, this one's also completely closed. If you want to split along something that's completely closed and let it quote-unquote auto-cap it for you without having to actually cap it yourself, or do all those steps I just showed you again, then there is something called Boolean split. Now this only works for objects that are completely solid, like this one, or this one, or this one, so be mindful of that. So we type in Boolean, and there's a bunch of Booleans, and I will go over that in the next tutorial, because that will be transitioning from polysurfaces to carving, quote unquote, and all these other things, and do split. And now, once we type in Boolean split, you select surfaces or polysurfaces to edit, and select this, and hit enter, and select the cutting surface or polysurface. So this Boolean split requires a surface to be used as the cutting object. With split, you can get away with a curve, but you still would rather use a surface. But this one requires it, so we're going to click this and enter. And now we see the seam is created here. So now if we hide this and hide this, we can see now we have it perfectly split along and capped, right? And you're like, is it really capped? Is it that good? Yes. See? We found 9 edges, no naked edges, and no non-manifolded edges. That's pretty cool. I like Boolean split. I use it a fair amount because it saves a lot of time. You don't have to do all that auto capping. You don't have to do edge surface. You don't have to do any of that. This is the way I think. And once you have it solid, you can now manipulate it. Like if you have site ground and you want to manipulate kind of carving actions into the ground, that's the way to do it, is to literally just start Boolean splitting as long as your ground is solid. And that's why modeling as real life is somewhat important in this program. But yeah, so this is a good transition and stopping point to transition into the Boolean kind of command series I'm going to go into. So yeah, that's pretty much it for this part of the tutorial. Thank you guys for watching. Hope you guys have a great day, and I will see you guys on the next part of the video.